Hey, I will be at the veterinarian's tomorrow morning, very early, and I don't know how long I'll be there taking care of Annie. So um, I will offer this to you. This is what we would have gone over in class tomorrow. You've started on it. I would have gone over it. We would have had presentations, but this gives you an opportunity to see uh, what my thoughts are. I've posted both the notes and the PowerPoint without my recording on Canvas already, so you can look at that. It usually takes about an hour to or so to process the files, and then I have to upload it to YouTube. But anyway, so I haven't decided if I want to actually assign that football problem. It's an outstanding problem. It covers really almost everything that I think is important. So I may do that, but right now uh, I'm inclined not to. I've got a lot of other things to do and things going on. But what I would really like is for everyone to do it. And to assign it is a motivator. Anyway, it's a great problem. So this is converting to standard form. This is not in standard form. It's in kind of a general form. And so this is that completing the square process. Uh, if your question is, why do this? Why the particulars of the process? There's nothing else works. The idea is to get it into this form where it's some coefficient times x minus h quantity squared plus some number k. And clearly it's not, right? It's x squared, no parentheses. And then there's this xx and what's going on there. So the only thing that will work is this, to add 0 in a special form. And the special form that's needed to get this perfect square is always going to be, look at the linear term that's plain x, not x squared, not the constant, plain x, x to the first power, and look at its coefficient, in this case 6, and then divide that by 2, and then square it. And of course, to keep everything balanced and not to change anything, I have to subtract that away. So I add it in, and then I subtract it away. And nothing has changed. Content-wise, it looks different, right? And so I'm going to write this as 6 over 3, or 2 as 3. I'm going to leave it as 3 squared so that I can focus on these 3 terms, right? I want to focus on these 3 terms, and I want to group those together in just a minute. But I am going to work this one out. This is subtract 6 over 2 is 3, squared is 9. So when I look at these 3, because of this choice, this peculiar choice, this is now a perfect square, right? It's x plus 3. That's why I've left this as 3. X plus 3 quantity squared. And then I've taken negative 9 and 5 and added that up. And remember, there is a 1 there, but what's the font color? It is white. So you can't see it, right? You can't see the 1, but it's there. It's just white font. So now, if the question is, why do we bother with this? One, good algebra workout. But the most important reason is this. I can look at this and see A is 1, which means it's an undistorted parabola. There's no stretching or compressing. And it's positive, so it's cup, not cap. The vertex is negative 3 comma negative 4. Just by looking at this, right, it's a subtract negative 3 and then a plus a negative 4. I can see the vertex, which is very important. The single most important point. Here's the algebra workout portion of this. You're given that the vertex is negative 1, and the point 2 comma 5 is on the parabola. find the standard form of the parabolas, and that's equation. Sometimes I can't write all of those letters. It just won't come out of my hand or typing. So here's the standard form. I need to figure out what A is. I need to figure out what H is. And I need to figure out what K is. Oh, wait. I was told what H and K are, -1 and -1. So I'm just going to put those in and see what happens. I don't know what to do with this yet. So I don't know what A is, but I put this in, -1 in for H, and I have K plus -1. Well, X subtract a -1 is X plus 1. Nothing to do with A, I don't know, and plus a -1 is more simply written as subtract 1. Okay, so it's not done because I don't know what A is. Well, evidently that's what this is for, right? That's what this thing is for. Whoa, I did not like that. I'm going to erase it. Okay, what is that? Laser pointer. Nope, didn't like it. That was way too. Okay, so I want to find A. All right, so I'm going to use that. And so the first coordinate is 2. The X coordinate is 2, and the Y coordinate is 5. So X is input, Y is output. X is the independent variable, Y is the dependent variable. X and Q of X, right? Input, output, X, Q of X. So the idea then is to, in this formula, which we're almost there, take the X and put it in. And this is then put 2X into the formula. And here it is put into the formula. And we're told that when that's all worked out, that's equal to 5. So A has to be that number that when it's plugged in, it all works out, this whole mess works out to be 5. So we have A times 2 plus 1 is 3 squared, minus 1 is 5. So I've added 1 to both sides and I get 6. And 3 squared is 9. So 9A is 6. And A is, then divide both sides by 9. And so A is 6/9, which of course I would never write, and you won't either. It's 2/3. All right, so that's the missing piece. A is the missing piece. There it is, 2/3 times the quantity X plus 1 squared minus 1. So it's shifted to the left, dropped down, and compressed, squished a bit. Those are the transformations that are happening in there. I'm just throwing that in as a bit of a review. And we need to get moving here. If the video is too long, you're never going to look at this. So the idea is to graph this thing, x squared minus 6x minus 7. What I've done here is just review the little, the step-by-step pieces that I... Okay, another glitch. I think it's going to be okay. So note that the A is the number 1. It's in white font. You can't see it, but it's there. And it's a positive 1, so it's a cup. And the formula for the vertex is look at B, divide it by 2A, and then whatever that number is, plug it back into the formula. So you'll see this here. I've taken B, which is -6 here, -6, taking the opposite of it, divided by 2 times that hidden 1, the white font 1. And let's see here, -6 is 6, divided by 2 is 3. So I'm going to take 3, plug it into the original formula, and here's 3, right? I've just calculated this. So I'm taking this and putting it back into this, right? And you can see here, 3 squared, x squared, minus 6 times 3, minus 6 times 3, minus 7. So now I need to sort all that out. 9 minus 18 is -9 minus 7 is -16. All right, so that's the vertex. X-intercept, I have to set the whole thing, the whole formula to 0. That's where y, or q of x, is 0. This happens to factor, but just use your calculator. Use the one that I recommend. And so I find out that x is 7, x is -1, and of course y is 0. And then for the y-intercept, just plug in 0 for x. And into the original formula, as 0 squared, minus 6 times 0, minus 7. And there you have that. And I've put all that together. I have my 2x intercepts. I have my y-intercept. And you can see that it's a little hinky because the left x-intercept should be just as far away from this axis of symmetry as the right. But good enough for, just visualization and label. Got to know what that thing is. Okay, 10 minutes, got to get going here. A rancher has 120 meters of fence and wishes to enclose a rectangular region along a river, which serves as a natural boundary, requiring no fence on one side. What is the maximum area that the 120 meters of fence can enclose? What are the dimensions of the maximal region? So I've drawn a little picture. Here's the river. There's a rectangle with a base and a height. None of this length and width. No, we're at the university, okay? Base and height. So what I do know is that a base plus 2 heights is 120 meters. That's all the fence. It gets used on 2 bases, 2 heights and a base. And kind of thinking ahead, I'm going to subtract 2h from both sides so that I have an expression for base that involves numbers and the height. Well, the formula for the area of a rectangle, it's a rectangular region, even though it's not, the river is not a fence side, it's still a rectangular region. And I need to write it as a formula that just involves h. That's the requirement. Unfortunately, the area of a rectangle involves 2 variables, base and height. So until you get to Math 126, you're doomed. I'm not doomed, you're doomed. Oh wait, no wait, you're not doomed. Because here's a way, right? Here's a way that when B shows up somewhere, here's an equivalent expression that has just numbers and h's in it. So I'm going to take this right here, this B, do it purple, do a nice purple. This B, all right, I'm going to plug it in right there. Some great mouse work. Right, that's that up there. And so now if I distribute that through, I get 120h minus 2h squared, which is quadratic. Thank you very much. So a is the coefficient of h squared. It's not the first thing. It's -2. It's whatever's next to x squared, h squared. It's a negative, so I have a cap. So that means I'm going to have a maximum. So the vertex is found by the same formula as before, negative b over 2a. So b is 120. So 120 over 2 times a, which is -2. Let's see here, -120 over -4 is 30. So I have to take 30 and plug it into the formula here. So I have 30, and then here you can see 120 times 30 minus, let's do peach. Okay, peach. Kind of a peach here. See the kind of a peach. The 30 here. This 30 gets plugged into there. So 120 times 30 minus 2 times 30 squared. And that's 1800. And that's the A. Why did I use the letter A? Area. So the maximum area is 1800 square meters. Okay. The height is right here. That's this. This is h, 30 meters. Then if I want to find the base, it's just 120 minus 2 times the height. So I plug that in there. And I get 60 meters. Pretty cool problem. So now projectile is fired straight up, not this, right? It's straight up and straight down at 19 meters per second. Its height above the ground in meters after t seconds is given by this height above the ground. And this is acceleration due to gravity near the surface of the Earth. This is the launch velocity. And it's launched from way up somewhere, 120 meters up. So it's a cruise missile or something. Was the projectile fired from the ground? Nope. What was the maximum height the projectile reached? When did the projectile hit the ground? Okay, we can answer all of those questions. So the question was it launched from the ground? So the launch occurs at what time? 3, 2, 1, 0, right? When t is 0, what's the height? So plug it into the height formula, 5 times 0, negative 5 times 0 squared, plus 19 times 0 plus 121. 121 meters. It's way up there. So launch from a balloon, right? From a balloon, or I don't know. Yeah, these things happen. And let's see, the lead coefficient, or the coefficient of t squared, is negative, so it's a cap. So we're going to get a extremum, that is a maximum. And here's the vertex formula, and I've plugged in the appropriate values. I get 1.9, I plug that in, and I get 139.1 meters. It's going on very long, so I'm going to be a little bit brief. Hit the ground means the height is 0. So I solve this. I use the quadratic formula. I just wrote it down there for you to see. I didn't use the quadratic formula. I just used my calculator. And the negative means that in the model, in the quadratic model, before the launch, it would have been on the ground, but we're interested